Okay, welcome back. Yes, I just enabled, I configured the live stream in YouTube. I hope you are able to see it. Let me check for the link for the stream. Moment. Okay, I think I will share the link of the stream with you, so you will be able to check the recording of this session. Can you tell me if you're able to open the link, please? Okay, very good. Thank you. So yes, I will post all the videos there. Actually, there will be a live stream. It has a bit delay, so don't worry. It's fine. And yes, very good. Okay, so we can start. With the presentation again. So, are you able to see the presentation? Okay, let me check. I think so. To not let the same issue again. Let me check if all of you are able to see the presentation. I think you should be able to see the presentation now. Are you? Just to double check that everything's fine. Thank you. Very good. Okay, so yes, today we'll also discuss. We'll have good introduction, not short, not long, but fine introduction to Java. We'll discuss some basic design principles of Java, main benefits of Java as a programming language, and also we'll discuss the Java technology stack, how Java work, how it's built, how it is configured, and how does Java work. Also, we'll discuss Java virtual machine. What is it? What is the purpose of Java virtual machine? Why do we need Java virtual machine? We'll talk about how the Java programs are executed. The way, what do you need to execute Java programs? In which cases it will work, in which not. And which IDs to use for which development environments you can use for Java. So, why Java? As you probably know, is one of the most popular programming languages in the world right now. It is used in many banks, retailers, insurance companies, utilities, manufacturers, and it's also used in different SAP products, SaaS application products. You probably heard about it. It uses most of the SAP products use Java as the base programming language. So in this case, if you know Java, you have lots of opportunities in all these areas and also in many different areas which are not covered here. Java is a very popular programming language, and in my opinion, the main thing for Java is that you can use your knowledge in Java as the basement to learn not all others, but most of other programming languages. So it's a very good base for everyone. Right? Yes, it's the language with the most features used in other programming languages. The most with the main principles. Java has all the main principles, all the main features of object-oriented programming. So in this case, in my opinion, and it is said that not only by me, but for all the people, that Java is the general language for object-oriented programming. Java is very popular as the language where, actually, as it said, everything is based on the objects. It's quite true. There are some exceptions, but in general, Java is maybe the most object-oriented programming language in the world. So yes, in this case, it's very good. If you learn Java, you learn object-oriented, you learn the main principles. Actually, maybe all, not maybe, but quite a lot of object-oriented principles. Maybe not all of the possible object-oriented principles in the world in programming itself. We will talk about it later. Which features are available in Java, which not, and we'll try to compare all the advantages and disadvantages of the features there. Of course, the syntax is very similar to other programming languages, mostly used in C, C++. We will not talk about JavaScript since I think, and we will talk about JavaScript in case of web development if we have time to discuss it. But Java is not the same. Java is not the same as JavaScript. So I hope every one of you knows that JavaScript is not the same as Java. So these two languages are absolutely different. But yes, in general, if you learn the syntaxes of Java, you will be able to switch to most of other programming languages easily. Right, yes, Java is statically typed, comparing to, again, to JavaScript, which has the dynamic declarations of the variables. In Java, everything is declared strictly. That if you declare the variable with the type, it will have exactly the same the type which is declared. You will not be able to confuse yourself here. In case the variable is declared, it will have the statical type, and it is easy to understand the code, easy to read the code, easy to understand the code if it's statically typed. So in this case, Java is not confusing as, for example, JavaScript or other script languages. Also, there are some disadvantages in this point that Java is statically typed. We'll talk about it later. From why, from my point of view, there are some disadvantages here. We'll talk about it later. And yes, the general point is that lots of softwares, lots of applications are built on Java as the main programming languages. So it's used quite often in lots of different places. Right, so where Java can be run? Everywhere. In desktops, mobile, embedded systems, and web. Everywhere. Why Java is good? Java has lots of different libraries available. You will find lots of related stuff. Actually, maybe you can, not everything, but most of the stuff will be available in Google, in Internet, in Stack Overflow, or other resources. I think it's very good that Java have lots of learning materials. In this case, it's very easy to learn Java, to start with Java. So it's very good that you can find help practically everywhere. It's very good. Of course, since Java is a very popular language, it has regular updates and improvements. So in this case, maybe sometimes it's not possible to catch all these improvements, to go in time with all these improvements. But in Java is very developer friendly in this area of updates and improvements. So it's not very hard to switch between the versions and updates. We'll talk about it later. And yes, there are no signs that Java is declining in use. It's true. It's one of the most popular programming languages in the world. Yes, the good thing comparing to other languages is that the code written 15 years ago will still run mostly. It will still run today. But again, we will talk about Java Virtual Machine today later, and you will find that it is it depends on the hardware the program is executed on. In this case, time by time, actually it means that the code you wrote 15 years ago, now it will run even faster than it was in that time. It's very good. Right. Again, let's go a bit deeper. Why Java is very good for learning. It is influenced by C++ and C#. Yes. So since a lot of students choose or used to have C++ as their first programming language, it's for them it will be very easy to switch to Java, since the syntax is very similar now. Of course, it's English-like syntax. So for those who don't know English, it's it's easy to understand the code. Of course, there are some tricky points there, but in general, it's easy to understand what is written in Java. And yes, as I already mentioned, there are so many frameworks and libraries built on Java and available on Java, so you don't need to write some basic stuff like 1,000 and more times yourself. You can just reuse an existing library there and use it in your code. And yes, as I said, there are many IDEs for Java. You're welcome to use every of them. Right, so to just a bit summarize where Java skills can be used: building Android applications. We will not talk deep of Android development, but just to know that Java is used in the building of Android applications, in so many web applications which are built in Java, software tools, some scientific applications. For those of you who may be familiar with statistics, lots of programs built for statistical purposes are built in Java. As well, lots of games and graphical tools, lots of stuff built in Java. Right, let's talk about the main principles of Java as the programming languages. As I said, it's object-oriented language. In jargon, it is said nouns over verbs. So it means that on the top there are objects, nouns, from which you're able to execute the methods, in which you're able to store the data, to do the connection between the data there. We will talk about it, but it's a very object-oriented language, and everything is based on the object. Almost everything is based on the objects in Java. Yes, as you maybe already know that code is structured in packages, which contain classes. So packages are often used in Java. The approach of packages is very important in Java programming. It depends on namings of the classes. Mostly everything depends on the packages you use and you are working with. So just be sure that you are not confused here. Yes, and why Java is not fully object-oriented is because there are different primitive types like byte, short, integer, long, float, double, character, and boolean. These are primitive types which are not objects, and everything else is considered as object. Yes, as you probably noticed, there are two ways of coding approaches: imperative and declarative. We'll not go deeper here. In case you're interested, you can read the description. I will share the slides with you. So in case you want to understand the concept of imperative and declarative approaches, you can learn here by clicking on this link. Just in general, again, there are two approaches. First one is procedural. Procedural approach belongs to imperative, and object-oriented approach also belongs to imperative approach. And another approach is declarative, like SQL. If you just want to ask for the data, like it is considered as declarative approach. Otherwise, you have the procedures like do that, go step by step. it is considered as imperative approach. Yes, and just for example, how to understand these two approaches is if you arrive at Red Lobster restaurant and you approach to the front of the desk and say, in case of imperative approach, you would say, I see that table located under the non-fishing sign is empty. My husband and I are going to walk over there and sit down. This is considered as imperative approach. So you have step by step what you will do, what you do. And the imperative approach is quite simple. You just ask for a table for two, and that's it. So imperative approach is considered as how would you do something, and declarative approach is what you want to do. Different programming languages use different approaches here. Java uses imperative approach. Another principle is that Java is used for some network transferring features. That's true. Transfer the data, to fetch and to put the data to the network. Yes, Java is used there. There are so many libraries and frameworks built for this purpose, for networking. Yes, that's true. Yes, Java is used for many applications again. It's true. Java is safe because each application is executed in separate sandbox, and they cannot be interacted to other machine. And that's true. And yeah, the good thing for Java is that it is not it's platform independent. So if you have the code, if you have the Java virtual machine, code can be executed in any operating system, using on any hardware, right? So in this case, it's very good that you don't need a special platform to run Java code. The main principles, again, there are error handling, where exceptions are called in coherent way. It means that all the exceptions are considered as classes, right? And the parent classes will catch the exception of their subclasses. And yes, this is the way exceptions are called there. High performance, which depends, as I said, it depends on hardware the Java code is run on. Right, again, static typing, which has its own advantages, like minimizing the amount of runtime errors. It is easier to, actually, it is possible that everything is checked during the compilation and you don't have any errors relating to the data type you are using. And again, yeah, it's easy to read and check the code. Yes, dynamic execution is used for Java, that classes are loaded only when it is needed to execute them. All the components can be gathered through the network. Yes, it's true. You can use Java this way. Java can be used this way. And interchangeable implementations. Yes, Java use standardized API, and it is possible to use different implementations of the same libraries in Java. Sometimes it's a bit confusing, but it's good that there's such option there. Let's talk about Java technology. Originally, Java is developed by Sun Microsystems. At the beginning, there was Java was had been developing with in the team of, let's call it the team, Sun Microsystems, Oracle, IBM, and at first stages there was Microsoft as well. Then they left the Java, Microsoft left Java there, and because actually Microsoft didn't think that Java has so many opportunities, and it will work fine with Microsoft. So Microsoft switched mostly to their stuff with networking, with net environment. So yes, and that's why, for example, Linux is considered as the best best system for Java. Not Microsoft. Microsoft Windows is considered as maybe the worst operating system for Java, mainly because Microsoft not really like Java. Right. So yes, there's Java's programming languages, standard API, and development tools. Application programming interface. It is bundled as two types of packages. The first one is Java runtime environment, which is used for execution of compiled standalone applications, applets, servlets, and so on. And the second one is Java development kit for compilation, debugging, and execution of application. For Windows and Mac, you need to download the Java from web, from Oracle web page, or something related to this. But you need to have to just you don't really need to execute the Java program. You don't need to have this development kit, but you need to have a runtime environment to at least run your code. Right. And the good thing for Java is that Java is open source, so you don't need any licenses and such like any special accesses to run or to build projects on Java. Right. This is how the Java platform stack look like. It seems to be complicated, but on the basement there's Java virtual machine. Oh no, on the basement, yes, there's Java virtual machine which manages all this stuff. You can check this schema later. We'll not go deeper here, but this is the schema how Java look in general. Of course, as I already mentioned, Java is used as the main language for Android development, but the problem is that the framework of Android development is absolutely not the same as base Java runtime environment we'll be facing here. It has absolutely different framework, and in case you will work with Android, sometime you will face this Android framework, which is again mostly based on Java. There are different programming languages there. It can be Kotlin, C++ as well, but yes, Android is built on Java as well. This is a short summary between the differences between Java virtual machine, Java runtime environment, and Java development kit. Yeah, first, again, the base is Java virtual machine. It's an offset machine that provides a runtime environment in which Java bytecode can be executed. Java runtime environment refers to a runtime environment in which Java bytecode can be executed, and the Java development kit is just a tool to build Java code. Again, users don't need it if you just want to run the code, but if you want to develop, you want to compile something, you need to have Java development kit. Right, as I already mentioned, there are some relatives, some other programming languages which are quite similar with Java. Some of these languages are interpreted by a Java program, and some are compiled to Java bytecode and JIT compiled during the execution as regular Java programs. So yes, they're quite related to Java as a programming language. Most of them can be compiled alongside with Java itself. is Clojure, Ruby, Kotlin, Scala, JRuby, and Jython. So it's similar to Python. In this case, yes, these two are script languages, and these four are not script languages, but most of them are becoming very popular now, especially Kotlin. So maybe in future, if you work with Java, it is most likely that you will work with Kotlin as well. And yes, just a short summary of what Java API is. Again, as I said, Java, it's a Java application programming interface that is used for all the classes, and as a part of Java development kit, which includes all Java packages, classes, and interfaces, along with their methods, fields, and constructors. These prewritten constructors provide a tremendous amount of functionality to a programmer. So you are welcome to use all the features of Java API. It's very useful for developers. And again, as I said, Java belongs to Oracle. So in case you have any questions or concerns, you can write to Oracle, complain to them if you are not like something in Java. But yes, Java belongs to Oracle, and most of the software stuff you need for Java development or Java execution, you'll find on Oracle website. It comes from there. All the announcements, news, you can find in Oracle. And the advantages of Java set by Oracle. You can get started quickly. Yes, it's fine. It's true. It's easy to learn. It has some powerful features, right? And the second point is not quite true, because you can write less code. You can write more code. It depends on the way you are coding. You can use as much libraries as possible. In this case, there will be less code. But if you want to do it yourself, that will be more code. Right? You can write better code. Yes, that's true. There are so many possibilities to do it in Java. If you use correct libraries, if you know how to use them, code will be better and easier to work with. You can develop programs more quickly, right? There are so many environments you can do it on Java. As I already said, it's not platform dependent, so you can use every platform, Microsoft, Windows, Mac OS, Linux, to run Java code. It's very good that you can run Java everywhere. Write once, run anyway, right? As I already said. And it's much more easy to distribute your software with Java. And some comments from developers. Yes, it's, as I already said, it's open source, so it's very good for developers. Java compiler, Java compiler is a specific thing for Java. It's just-in-time compiler. I will send a link, a very good link, so you can check. If you want, you can. I will share one link with you. If you are interested in the way Java compiler works, there is one good video. I will share it with you. In case you're interested, you can watch this video. It's about Java compilers and the way Java compiler is built. Right. Okay, I think we need to. I need to share the presentation once again. One moment, please. Okay. Yes. Again, there's a core API for Java with so many libraries you can use from there. Java memory model is built for garbage collection, concurrency, and debugging API. Comparing to C++, the garbage is collected automatically, so you don't need to take care of it. It happens automatically. Yes, there's high performance of Java virtual machine, which depends on the hardware. It depends on hardware you are dealing with. Right, the bytecode. Java is compiled to bytecode, and of course it can use the compilation from other programming languages like again Scala, Groovy, Ocean, and even Python. You can use the third-party tools. There are so many tools for Java, so many IDEs. Most popular are NetBeans, Eclipse, IntelliJ, for those who work with Martin here. Yes, so many tools are available for Java. Yes, so if Java is so popular that Java didn't take the world. Again, as it said, it's mostly because of Windows, because of Microsoft. There are so many things that Microsoft did that, and because of all these updates needed for Java, all these usual things for Microsoft, sometimes it's a bit complicated to deal with Java on Windows, unfortunately. And yes, you can see top programming languages. Java is one of the most popular programming languages in the world. And yes, let's go deeper with Java Development Kit. It has some tools. First one, Java compiler, Java interpreter of bytecode, so you can interpret it, the code in Java. Java Doc is document generation tool. GER is the type of archive used for Java classes, and the debugger. You can debug the code in Java thanks to the Java Development Kit. And yes, as again, Java application programming interface provides main functionality for Java software. And there are so many toolkits like Java FX, Swing, and Java 2D used for Java. And yes, we'll take a look on some of these. And yes, there is integration with lots of libraries in Java, right? Java virtual machine. Again, this is the basement for Java. To build everything for Java. We will not go deeper here. I'm not sure if it's really needed for us. Yes, this is the way the Java program is executed. So there is a Java file. It's a simple text file where the code is written. Then it gets compiled. Compiled to the file with the extension of class, which is bytecode, compiled for Java, and you can run it everywhere where Java virtual machine is installed. Windows, Linux, or Linux, Microsoft, and so on. or macOS, and so on and so on. Yes, what Java Virtual Machine provides: it loads code, it verifies code, compiles to native code, and executes it. Yes, the memory area, class file format, registers garbage collected, heap, and importing any photo errors if there are some. The internal structure is class loader. Yes, at first class loader, it obviously loads the class of Java. Then there's a method area, which stores all this runtime stuff, and still fills some metadata, the code for methods. And there's the heap and stack memory, which is a very important thing for Java development. You need to understand the difference between heap and heap memory and stack memory. And yes, here's the short summary of the difference. I think I don't have the slide for this, but actually I think I can show you the main difference. Let me share my okay. So to understand the difference between heap memory and stack memory, as you know, there are methods, voids in Java. Let's imagine that we have so many methods, and now we are in the code which executes this method. So we are inside this code void 1, void 2, and void 3, for example. So if we are here, and each of these, so this stack and each of these methods voids has its own memory, which is called stack memory, which is inside each of this method. So, for example, from this method, we're not able to access the memory of local variables in this method, or even from this method. So this is the stack memory. This is all the stuff which is located in particular in each method. But the heap memory is the memory which in theory is available for all these methods, and in theory you are able to access the memory from each of these. So again, for example, this method is called from this method, and this method is called from this method. Each of these methods have their own variables which are located in stack memory, and you cannot access from each of the methods the variables, the memory of another method. But heap memory is available for all these, during all the execution of the program. Right? Let me share the presentation again. Right? Yes, as I already mentioned, you cannot access stack memory globally, but you can access heap memory globally. Memory management again is last in, first out for the stack. Instead, since the method is execution of the method is finished, the stack memory gets cleared. So it does not exist anymore once the method is executed fully. But heap memory will be in place during all the execution of the program. Right? Okay. Again, let's go with the Java virtual machine, internal structure of Java virtual machine. And there's a program counter again, which manages all the stuff, all these methods executed during the program. Right, there's a native method stack again, as I already mentioned, and yes, the execution of engine contains virtual processor, interpreter, JIT compiler, just-in-time compiler, and so on and so on. Yes, as you already know, the starting point for each Java program is so-called public static void main with the provided arguments of arguments, which is an array of string. Yes, the public goes for the public, so we can access this method publicly. It's static, that means that we don't need any instance for this method, and we don't have any returning parameters. Actually, we have no place to return them, so it's just a void. Yeah, the main is the name of the method, so it's possible to execute it from everywhere. Right. Sometimes the method may be missed if you use Java frameworks, and this method is called from there. So in case you are inside the code, like you have a program which is executed, you are kind of you go deeper, and it's possible that then you don't need the main method, because actually the class is used differently. You don't need to use the particular class as the start of the execution. In this case, main method can be missed. But yeah, in general, this is the starting point for each program. Here is how it looks like. So we have source code is a .java file, with the text file with extension of Java. Then the code gets compiled. We get Java bytecode with extension of class. There's a network or file system. When we go to the class loader, we go down deeper to Java virtual machine, compiler, have an operating system, and have hardware there. So this is the standard path for Java classes. The class path. So the class path is also one of the basic things of Java. It instructs the namespace where the compiler needs to search for Java file. It can be set as environment variable in the system, in the operating system you're working in. I will show you an example how the class path work. Okay, let me see what's how to. So with Microsoft Teams, it's a bit hard to manage all this sharing stuff, but I will try. And I will stop sharing the presentation and turn it to the practical part. Okay, I hope. So, yes, let's test. This is all difficulty. Yes, but okay, imagine we have a folder. We have folder 1. Just 1. We have. Let's create a Java class. Yes, a simple class. Hello. Right, we can already put the extension of Java. So, and now we can. It's complicated. I need to switch between the between the pop-up screens there. Sorry, just because of Microsoft Teams. We will not be using Microsoft Teams anymore, but okay, so I created a Java file. Let's create the class, and it's public class. Hello world. Just know that the file name should be the same as the class name, otherwise it will not work. So every time the name of the file should be the same as the class name. Right? Let's create the method. I'll just print out hello world. Hello world, and just be sure that this file belongs to the first class, to the test1 class. So we will know that put that this is from the first class, right? Hello world test1. Okay. Moment, it's probably. Okay, so now what do we need? We need to compile the class. Let me open the command line. Let me share it. Command line console. First of all, we need to change the directory of the class. Let's change the directory we're currently in, and let's try to compile the class. To compile the class, we need to call Java compiler, Java C, and let's provide the name of the file. Right, as we can see, it's complicated to share the screen. Let me switch it again. So now we can see that there's the compiled file, compiled class is created here. Is the byte. This is the byte code. This is the bytecode, and yes. So let's try to execute this class, this method. Let me share the console again. I'm so sorry that I'm not able to share the whole screen this time. Okay, so now we are in this folder, test1, and let's try to execute the file. So let's run Java hello world. Right. As we can see, we have an error. Why we do have an error? Because we haven't provided the path of the place where Java Development Kit is located. To do it, we need to find where the Java Development Kit is stored. The bin folder of Java Development Kit is stored. Let me share my folder. Okay, so now we need to go to program files for Java. So, and here, sorry, here, and to Java. You see here is Java development kit installed. I hope it's installed for all of you as well. If it is not, then please ping me if you're not able to install it. I think it should not be a problem to install Java development kit for all of you. Right, and now we need to provide the address of this folder. Once it is, yes, let's set up the path of where Java actually is located. Right, so let's set up the path for Java. Right, and again we're still in this folder, test1. So let's try to execute the file again. As you can see, the file is executed with output hello world test1. Yes, actually, as I already mentioned, firstly the file of Java file needs to be compiled, and after that you can execute the compiled file. In this case it's hello world. And to explain you what the class path means, is let me create another folder. So let me switch my screen to the File Explorer again. Let's create a new folder. Let's just copy the Java file from here. So just switch, just change the output to test2 so we can distinguish these two folders. So in this, again, in this folder there's a file where the output is hello world test1, and this folder there's a file with output hello world test2, right? So again, let's compile. Let's compile the file again. First of all, let's change the directory. Use command cd and just copy the path here. And again, we can compile the file here. Now we have the compiled file in this folder, and let's check if we can execute this file here. Yes, we can execute it. We have a different output, and let's set up the class path. So as you can see, we are still located in the second folder, test2. But what we will do now is we will change the class path to the first folder, right? You can change the class path to the first folder. And as you can see, we're still, from the console perspective, we're still located in the second folder, test2. And let's execute hello world class now. And what you can see, despite the fact that we are in the second folder, and code from the first folder, which is written in the class path, is provided, is executed. So this is the concept of the class path. By default, the class path is set to current directory. So at first it was set to the second one. No, at first it was set to the first one. In this case, in this case it was set to the first one. Then once we change the directory to the test2, the class path became test2, this one. And yes, now if we execute Java file, it will firstly look to the first to the directory provided in the class path, right? And this is almost it. This is practically it for regarding the class path environment. And let me show one more thing regarding the compiler. So let's create another folder. Let's create another folder. Okay, let's just copy our world. I'll try that again. Have test3. Right. Let's create a new folder. Let's just copy the file here. And as you can see, we have no any compiled class here, right? We just have a Java file. Let's change the class path. Again, so I'm not able to see my screen. See what I'm doing. Change it to so as you know, we don't have compiled class there, right? And you can see that in this way, we cannot execute it. We cannot execute it this way. But if we write the same Java, right, and we provide the extension of the file, in this case it's Java, and what does it do? It compiles the class. Oh no, actually it. Sorry, we need to change the directory. In this case, the class path will not work this way, but in case we are in the directory, try to execute hello world this way, and as you can see, the code gets compiled after we run the file, and we have the output. Right, this is all about the class path for Java, and I hope you have at least first knowledge what is the class path and how does it work. Let's move on. Yes, yes, sure.
Can I ask a question?
Yes, sure.
You use commands cd and set a class path.
Yes.
Is it common for all system? I use Linux, for example. I can use the same command.
I think yes, you can use the same. You can check it after the lesson. In case it doesn't work, please ping me. I will check. I haven't used Linux for this purpose. I haven't used Linux at all, to be honest. But yes, please check it, and if you're able to check it, I think it should work. It should work, I think.
Okay.
Maybe there are some different commands in Linux. I don't really know, but please check and let me know if it doesn't work for you. Okay, let's move on with the presentation. Yes, talking about naming conventions for packages. And Talking about naming conventions in general for all the programming languages, for all the programming environments, first of all, from my point of view, as I see, as I understand, you need to check it. You need to check what are the naming conventions in your particular project you are working in. If you're talking about packages, classes, variables, even variables, methods, and so on, you need to first of all check how are all the stuff named in your particular project you're working with. It can be different. All the projects, different projects have their own naming conventions. So please follow the guidance, and or at least check other code written in the particular project you're working with. Right, but in general, in most cases for packages, they are named in lowercase, for example this way, and they're structured and were separated with the dots. So in this case, the GTM is the parent, and this is everything what is after the dot is like a sub package of GTM in this case, for example. And yes, priority starts from higher and goes to lower. And yes, dots are used as a separator of the structure. And yes, it contains, as again, packages contain the classes, interfaces, and all this stuff. Right, which Java development kit to use? Yes, Java implementation to use. Practically everything is implemented in OpenJDK. It's maintained by OpenJDK community, Oracle, IBM, SAP, Red Hat, Amazon, Microsoft, and all other companies. But yes, Java development kit is based on the code written from different vendors here, like from Oracle, Red Hat, but it's all gathered in OpenJDK, but it has different vendors. Just for knowledge, it's not really important. Yes, there are two ways of the packages: Java runtime environment, libraries for Java runtime, and Java development kit, libraries and tools for compilation, testing, and debugging stuff. Yes, very important thing for Java environment is you need to assess the version of Java development kit you are using, and as you can see, since the release of the 8th version, there are so-called long-term support versions. Like in this case, it's the 8th and the 11th version, and there are some short-term support versions here. Again, yes, as you can see, the approach all these versions are updated. It's changed since the 8th version, and this is because Java is a very popular programming language. The popularity increases. All these environments the Java is used in, it's changing time by time. So there are so many different things need to be adjusted for different environments. In this case, it's very important to have up-to-date environment, and that's why there are so many short-term support development. It's created for Java, but don't worry, most of them belong to long-term support. So if you have the 8th one, it will go for a long time, for much longer time than those short-term support. And yes, as you can see, there is a time period where the 8th, for example, in this case, the 8th and the 11th version can be used at the same time, but time by time, actually, it's quite like, as you can see, there are two versions, and it has changed. So 10 by 10. Java, in case there is a code which is deprecated in the 8th version, for example, Java will ask you to refactor it, to change it, to adapt it to a new version. But it's like very specific stuff. It doesn't happen so often that you need to actually change all the code you've written on the 8th version to run it on the 11th version. Comparing to Python, which do not have such thing that the 11th version can be run with the 8th version in this time frame, in this time period. Actually, in Python, if a new version comes, you must change it and adapt it to next version. So it's not possible to use two versions in the same time. Right here you can see the time period for the release dates of Java versions. In my case, I use the newest one, 14th one. For those of you who join development in September, you will most likely use 15. It's fine, but I will use the 14th one. Right, and yes, another point is which IDE to use, which environment to use. We'll use Eclipse here in this course, as I said, mainly because it is used as the IDE in the course. This course is based on. So we have Eclipse. It's an open source. Everyone can download it. Has good support for different projects. It's true, and there are so many plugins you can use with Eclipse. Right. This is it for theory today.
Can I ask a question?
Yeah, sure. Yes, any questions?
So about the environment.
Right.
I'm thinking, let's say if I use two computers, if I use Eclipse on one and IntelliJ on the another, will I be able to, continue the code?
Yes, yes. For this purpose, we need the Git. This, all the code can be stored in cloud. We'll use Bitbucket. In this case, you can move the code from one environment to another one. So
will we use it like from the very beginning, or sometime later?
Yes, we'll use it from the beginning. You'll have practical tasks, which after you finish them, you can just put them in Bitbucket, and I will check this. I will check the code there, and you can reuse it for the purpose to use it in different environments.
Yeah, thank you.
Yeah, you're welcome. So, any other questions regarding to the theory? No? Okay, then we can switch. We have time to prepare. Okay, we can prepare the environment. Let's start preparing the environment here. Okay, we have half an hour for today. Okay, I think we can start, and let's see. Okay. We can just start preparation. You don't need to prepare the workstation if you work on Windows or Mac. This is meant for those who work on Linux. If you work on Linux, you can. No, we skip this. It's not needed for us. The first topic is not needed for us. It's just for to install Linux, but we will not use it. Okay, so right, I hope you know how to download the Eclipse. Just go to the Eclipse website and download the Eclipse. And press download. And here you can just download it. I will not do it because for me it's already installed, but in case you need Eclipse, you can download it from here. Alright, I hope it's very easy to install Eclipse. There are no, just press next, and then press finish, as it usually happens. So it's hope you will not have any problems with this. Right, so once the Eclipse is installed, you need to have workspace. Let's start from, let me show from
yes. I'm sorry, question.
Yeah.
So is it necessary for today to have the Eclipse, or we?
No. I would just show the first steps, how to proceed, and maybe the home task for Wednesday will be just to prepare the environment. I mean Eclipse, all this Java virtual machine. So you need to install the Java on your computer, so you will be able to work on Eclipse, right? Is it fine?
Yeah, I mean, I think we did that when we started, in the first course.
Okay.
Like installing the Java and putting it in somewhere.
Yeah.
I forgot there, but yeah.
Yeah. Okay, it's fine. Yeah, it's fine.
And right now it's just like we have the IntelliJ, at least our group, like Java 7, we have the IntelliJ. So the question is, do we need to, if I can use IntelliJ, I would rather not, install something else.
Yes, sure, you can use.
So,
yes,
but
you can.
The question is, will it work?
Yes, since if the Java code is correct, why it's fine if you use it. So it can be used in all the environments.
We can stick with IntelliJ.
Yes, you can stick with IntelliJ, but I will show everything on Eclipse, right? But yes, it's fine. I think it will be fine if you work in IntelliJ. In case you have any problems, just ping me. I will try to solve the problems if we have such, right?
Yes. Okay.
Thank you. Okay, so I hope we have it's a bit time. So yes, okay, just install Eclipse for those who need IntelliJ. If you're fine working with IntelliJ, it's fine for me as well. And okay, so first you can see there's
one question about this installation. Which option do we need to choose of these? ID for Java developers?
For Java developers, yes, we need for Java developers.
Okay, thanks.
Right. Okay. Right. So once the Eclipse is installed, there's, as you can see, there's a zip file here. This is the project built for this course. We'll use this project during the whole course. So yes, first we need to install this project, or to download this file, this archive, and after that, let's go to the Eclipse. So for every Eclipse, to work with Eclipse, you need to have the workspace. It's just a folder. You we chose the folder you are comfortable to work in. Just let me show my folder just so it is clear for all of you. In my case, I just have documents, Java lessons, Eclipse, and there's workspace here where we'll be working. Right, so let me open the Eclipse. Okay, so it asks to choose the workspace. Again, as I said, you can use this folder. Usually you will have, not usually, but in general you will have the only workspace. You don't need to switch between them. It's not needed. You just have one folder there and use it for all your tasks. Let's wait until Eclipse is started. Okay, I already have some projects here. Actually, we will not use it. So, at first, just one moment. I just need to delete some files for the testing purposes.
Artur, I'm not sure if you mean it this way, but we don't really see your screen.
Oh, sorry. Yes. I think. Okay, that's again the problem of Microsoft Teams, that it does not allow me to share the whole screen. Okay, so now it's fine. You have not missed anything. So okay, now I think you should be able to see the screen. Okay, so yes, we have downloaded the file, the zip file, and now let's from AutoLV. It's exercise. That's exercise 2. Second topic, preparation for Java workspace, Java project. And let's again load file, import, and here you have some options. In this case, just choose general. Existing project in workspace, like this one, existing projects into workspace. Then we select this option, select archive file. I have file here. In this case, let's just browse, and here's the file we just downloaded. Right, so just select it and press finish. Let's wait until it is loaded. And as you can see, there are so many errors here. It's fine. Why it has happened? It has happened because there are so many dependencies, there are so many libraries used in this project which actually do not exist on our computer. Let's open the POM file. This is the root of the project, and as you can see, there are lots of dependencies here. which need to be solved. So how to solve it? Let's just go step by step what is written on the OVAN. Right. Yes. First of all, to fix this, you need to install Maven. That's Maven is the tool that helps solve all the dependencies of the project. So, okay, let's do it. I think we have some time today. We can install Maven, and yes, to use it to install Maven, let me share the link with you. So this is a good tutorial to find how to download and install Maven. So I'll just share it with you. And okay, let's just go step by step. So first of all, you need to install Apache Maven. Let's go to the Maven website. This is just a tool to solve all the dependencies. And let's download Maven from here. So you need to download the bin file, right? Okay. See the files downloaded, so we have a zip file here. It is already installed for me, but I will try to show it to you as well. So let's wait until it is downloaded. And we need for those who use Windows, we'll configure it now.
I have a question.
Yes, sure.
Do we need this if we use IntelliJ?
I'm not sure if did you install Maven before or not?
I think not.
Okay, then I think you will need it anywhere, since basically you need to download all the dependencies for your project. In this case, all these dependencies are files, and if you don't have the files, you're actually not able to work with the project anyway. But yes, you will need it. You will need it anyway.
Thank you.
But yeah, just double check from your side and ping me if you have any issues there. Right. You have some. Okay, I think we have some issues here, and I think I'm not sure if we were able to manage it to finish it today. So, okay, I think for you at home, you can. That would be the home task for you. Just first, for those who need, please install the Eclipse. For those who don't want to use Eclipse, you can use IntelliJ. It's fine. Yeah, that's the first step. The second step, please download the project from here. This one, just download this file. This is the first step. And the first step is try to try to install Maven. Just for Windows, follow these steps, all these steps, which are here. I already shared the link with you in Teams chat. I will also, since this link is very important, I will also share it in Java 7 course here, right? And yeah, just for those who use different system, just you can just Google it, for example, how to install Maven on Mac, for example, right? There's tutorial. There are some tutorials here. You can just find them. In case you have any issues and you are not able to install Maven, please ask me. I will try to help. But for those of you who use Maven, just follow this step. And after the Maven is installed, you can. Okay, I think it's enough for you to just install Maven. For next lesson, we'll go further with. Yes, sure. I can share the link for Java 7. Yeah, actually, I think I'm not able. I don't have permission to. I don't have access to add you to Discord. I'll try to add you to tomorrow. I think I will add you until Wednesday to Java 7. Okay, I just have a link here. Let me. Okay, I have a link here. Please check if you're able to join. Yes, I'll share the Java bootcamp. Share this as well. Oh, nice! You're all joining. It's very good. Very good. Okay. So yeah, just home task for Wednesday. Just open this training course. Check how is it concentrated. Do the first steps of the preparation of Java project. Be sure that Eclipse or other the environment tool is installed on your computer, so we'll be able to work. We'll be able to code in Java. That's the first step. Again, the second step is import the project to your environment, and the first step is try to install Maven on your computer. After that, just check if Maven is installed. We'll proceed with further steps here, right? Okay, I think it's pretty much it for today. Any questions? Okay, so thank you for joining today. Thank you very much. Let's hope you will do great on this home task, and let's see you on Wednesday.
Thank you.
Thank you.
Thank you.
Bye. Thank you.
Bye.
Bye.